Folks, today's lesson is an expression called the difference of two squares. The difference being the subtraction of, and two squares being, believe it or not, two things squared. So let's crack on and get the job done. 5 squared subtract 2 squared is an expression of the form the difference of two squares, because we've got a subtraction sign, meaning the difference of, and what are we subtracting? Two things which are being squared, 5 squared and 2 squared. That would be 5 squared, represented by 25 little squares, 5 by 5. That is 5 squared. And from that, we're going to subtract 2 squared, which would be 4 squares. So the number of yellow squares that you see now is 5 squared minus 2 squared. If we take that block in the top corner and move it down to the bottom corner, we can rearrange those same squares into a rectangle. What's the size of the rectangle? Well, whatever the size of the rectangle is, it must be the same as 5 squared minus 2 squared. Well, it's a 3 by 7 rectangle. But where do we get the 3 from? The 3 squares are the original 5 squares with 2 squares here subtracted. So consequently, this 3 has come from 5 take away 2. And where does this 7 come from? Well, it's the original 5 with those 2 added on. So 7 is actually 5 plus 2. Therefore, the number of squares we have is 5 plus 2, which is the 7, multiplied by 5 minus 2, which is the 3. So we can rewrite 5 squared minus 2 squared as 5 plus 2 in brackets 5 minus 2. Let's look at a second example so this makes even more sense. First of all, what you're looking at there is 7 squared. A square which is 7 by 7. There are 49 little squares there. From that, we're going to subtract 3 squared. 3 times 3 is 9, so that's that little block of 9 squares taken away. And the number of squares that you see left, the number of gold squares that you see left, must equal 7 squared minus 3 squared. But we can take the block in the top left-hand corner and replace it down in the bottom right-hand corner to form a rectangle. How big is the rectangle? Well, it's a 4 by 10 rectangle. But where did we get the 4 from? The 4 is the original 7 minus these 3 squares. And where does the 10 come from? The 10 is the original 7 squares with these 3 added on. So in fact, the dimensions of our rectangle, 4, is actually 7 minus 3, and our length of 10 is actually 7 plus 3, which means we can write 7 squared minus 3 squared as 7 plus 3 brackets 7 minus 3. Here's example 3, and it might be coming clearer to you what we're going to do. We start off with a block of 8 squares, 64 little squares. And from that, we're going to take 5 squared, 25 little squares. So that's a block of 5 by 5 taken away. So the number of gold squares left that you can see in that L shape is 8 squared minus 5 squared. But we can take that top block and replace it in the bottom right hand side to form a rectangle. And the rectangle is obviously the same size as the L shape. How big is the rectangle? It's 3 by 13. Where did the 3 come from? 8 take away 5. And where did the 13 come from? 8 plus 5. So 8 squared minus 5 squared can be written as, in brackets, 8 plus 5, in another bracket, 8 minus 5. We can generalize this using algebra. Here's how. That's our original square, a squared, a by a. And in that corner there is b squared, a square of b by b. If we cut away that corner, that b squared corner, we're left with an area which is a squared minus b squared. And there it is, up in the top right there, just keeping it safe. But keep your eye on it. Now let's look at what we've got left in our L-shaped block. Well, these lengths must be a minus b. Why must they be a minus b? Because the original length across there was a, and we've taken away this little corner here, which was a length of b. So that's why that's a minus b. And similarly, this side here originally was a side of length a, but we've taken away a side of length b from it. Hence what is left is a minus b. If we then, just with a little bit of rearrangement, let's just put some dimensions on there, okay? Clearly this length was a minus b, so it's the same on this side, a minus b. And this length here was b, so clearly that's b there. And now I'm going to take that top left-hand block and replace it down on the right-hand side. Now the question is, how big is the rectangle that we have now formed? Well, that length there is b, and therefore our base of the rectangle is a plus b. Our height of the rectangle we can see is a minus b, so the area of our rectangle is a plus b brackets a minus b. Hence, remember that this rectangle here, the area of this rectangle was the same area as this L shape. Told you to keep your eye on it, which means that a squared minus b squared, the area of the L shape, must equal this area, the area of the rectangle. And therefore we are left with, generally, a squared subtract b squared can be rewritten, can be factorized as, in brackets, a plus b, close brackets, and in a second bracket, a minus b. So let's try this with some examples. Example 1, x squared subtract y squared. Looking at the yellow box, we should be able to see that we can write that as x plus y times x minus y. In example 2, x squared subtract 9. Now just be careful here, because some students will immediately rush in and think x plus 9, x subtract 9. But 9 is not written at the moment in square form. 9 is just 9. But we know that 9 can be written in square form because it's a square number. So the first thing we must do is write the expression x squared minus 9 as something squared minus something else squared. It has to be the difference of two squares. So we can write it as x squared subtract 3 squared, because 3 squared is 9. Now our expression is of the form something squared subtract something else squared, so we can now write this expression as x plus 3 brackets x minus 3. Example 3. It's similar, isn't it, in structure to example 2. And we can note that 25 is a square number. So we can rewrite 25 as 5 squared. So now our expression is something squared subtract something else squared, which we can therefore write as a plus 5 times a minus 5. Example number 4. Now that looks like we've got two things squared already, but we need to be a little bit careful. The square here is only applying to the a. This is not 4a all squared. This is 4 lots of a squared. So it isn't quite in the form the difference of two squares. But we can rewrite 4a squared as 2a all squared, because 2a all squared means 2a times 2a, which is 4a squared. So these two things are the same. But now the right hand side is written as something squared, i.e. 2a squared, subtract something else squared. So it is in the form of the difference of two squares. So write it as 2a plus b, 2a minus b. Example 5, another little step up. First of all, 9 times a squared, or 9 lots of a squared, what would that be as something squared? I.e., what squared gives you 9a squared? And the answer to that question is 3a, because 3a times 3a is 9a squared. What do I have to square to give me 4b squared? And the answer is 2b. Therefore, we rewrite this as a difference of two squares by writing it as 3a squared subtract 2b all squared. And now we can rewrite that in bracket form, 3a plus 2b, 3a minus 2b. And finally, example 6 is very similar to example 5. Can you see what is being squared here to give us 25x squared? And what is being squared here to give us 9y squared? Have you got it? What squared gives us 25x squared? The answer is 5x. And what squared gives us 9y squared? Answer 3y. Now we have in this right hand side the difference of two squares. We can put it in our bracket form, 5x plus 3y, 5x minus 3y. So let's put that all together in a recap. The difference of two squares refers to expressions of the form a squared subtract b squared, or something squared subtract something else squared. The difference of two squares. A squared subtract b squared can be factorized and rewritten as a plus b in brackets times a subtract b in brackets. And finally, make sure expressions are in the correct form before factorizing. So for example, this might look like it's in the correct form, but what is being squared to give us 4a squared, and what is being squared to give us 9? We must think that first, and the answer is it's 2a being squared and 3 being squared. Now we can write that in our bracket form as 2a plus 3 brackets 2a subtract 3. And if there's anything about the video you haven't understood, just watch it back. And if you have, that's great, because that's the job done.